Hello everyone. So now we are going to discuss about RH criterion. This criterion is used for analyzing or for knowing the stability of the system. Now in this problem, he has given that using Routh criterion determine the stability of the system represented by the characteristic equation s power 4 plus 8s cube plus 18s square plus 16s plus 5 equals to 0, and is also asking on the location of the roots of the characteristic equation. Now this is our characteristic equation. So now the first step is to write this s powers in the descending order, that is s power 4, s cube, s square, s power 1 and s power 0. So this is the first step, and the second step is you have to write the coefficients of this s powers. Now the first term is s power 4. It is s power 4. Now it is even. So you have to consider the even powers, that is s power 4, s square, s power 0. Now write in the order. First s power 4, that is 1. The coefficient of s power 4 is 1. And the second is 18. S power 0 we have coefficient is 5. Now we have to consider the s cube. The coefficient of s cube is 8. We only have to consider the odd powers, that is s cube, s power 1, that we have to consider 8, 16 and the rest we don't have, so it is 0. So now the third step is you have to calculate the s power 2 coefficients. For that you have to consider in this way, that is 8 into 18 minus 1 into 16 by 8. You can also write 1 in the place of 8 and 2 in the place of 16. Or you can proceed with the same, that is 8 and 16. This is also correct and that is also correct. I have written 1 in the place of 8 and 2 in the place of 16. So now it will be easy for us to calculate because the coefficients are small. Now you have to take in this order. It is 1 into 18 minus 2 into 1 by 1. It is 18 minus 2 by 1. It is 16. So here we have to write 16. And the next is you have to go in this order. We don't have anything, so we can write here 0. You can write 1 into 5 minus 1 into 0 by 1. It is obviously 5. So you have to write here 5. In the same process, you have to calculate it again. It is 16 into 2 minus 1 into 5 by 16. You're getting 1.68. So you can write it 1.7. So when you calculate 16 into 0 minus 1 into 0 by 16, you will get 0. So you need not to write it. Now you have to calculate this. 1.7 into 5 minus 16 into 0 by 1.7. You'll get 5. So these are the coefficients. Now we can know whether the system is stable or not. So for this, you have to check whether you're having any sign change in this coefficients. you don't have any kind of sign changes. That means you are having, this is the imaginary axis and this is the real axis. So you don't have any sign changes. That means you are having all the poles in the left side. That means it is the stable system. If you find any sign changes, then you can say that the system is unstable. So here, transfer function of the system. Here we have A by S plus A. That means you are having the pole on the left side of the real axis. That means your system is stable, and this is the impulse response of the system. Here the pole is located on the left half of the side, so this system is the stable system. And when the pole is located in the right half of the side, then the system is said to have unstable, and this is the impulse response of the particular system. Now when you have the poles in the imaginary and real axis, then this is the formula to represent it. So when these poles are located in the left side of the S plane, so this system is said to be stable. So this is the case when you have poles on the right side, and that too you having in the imaginary and real axis. So then the system can be represented as like this, and you are having your poles in the right side of the S plane, then the system is said to be unstable. And when you have the poles on the this imaginary axis, that is on the origin, so then the system can be represented as like this, and the system is said to be marginally stable. And the last case is when you have this complex of the above one, and then the system can be represented as like this, and the system is said to be unstable. So from the cases that we have seen earlier, we can say that the system is stable because all the poles are lying in the left side of the S plane. So he has asked for us to comment on the location of the roots. So we can say that the system is stable.